Welcome to today's severe weather analysis for Wagga Wagga, Wednesday, November 26, 2025. We're examining the 10 a.m. local time sounding to assess thunderstorm potential for the day ahead. If you find this analysis helpful, please like and subscribe to support continued severe weather analysis. Looking at this morning's sounding, we are seeing a stable atmospheric profile with zero mixed layer CAPE. The Skew-T diagram shows the red temperature line and green dewpoint line widely separated through much of the atmosphere, indicating very dry conditions aloft. The surface temperature is 22 degrees with a dew point of 7 degrees, giving us a 15-degree spread that limits moisture availability. Notice the large blue shaded area representing convective inhibition, essentially a lid holding down any potential instability. The lifting condensation level sits at 1900 meters above ground, which is quite elevated. Wind shear through the lowest 6 kilometers is impressive at 50 meters per second, but without fuel in the form of CAPE, this shear has nothing to work with. As we heat the surface parcel to the forecast maximum of 28 degrees, we see a modest transformation on the enhanced Skew-T plot. The heated orange parcel path now generates a small pink shaded area showing 106 joules per kilogram of surface-based CAPE. However, the blue shaded convective inhibition remains dominant through the mid-levels. The mixed layer parcel, shown in blue dashes, still produces zero CAPE even with heating. The lifted condensation level rises to 2600 meters, and we can see the level of free convection marked where the heated parcel finally breaks through resistance. Allen's discriminant calculation gives us 73,000, which crosses the threshold suggesting scattered storm potential if initiation occurs. But here's the critical point. We have the wind shear needed for organization, reaching nearly 50 meters per second through 6 kilometers, yet the atmospheric fuel remains marginal at best. Looking ahead to tomorrow morning's machine learning forecast for late morning local time, conditions remain subconvective. The model predicts 0 joules per kilogram of CAPE and 0 surface-based CAPE, with wind shear dropping slightly to 23 meters per second. The lifted condensation level rises to 1600 meters above ground. Both the supercell composite parameter and significant tornado parameter remain at 0.00. Storm mode is classified as subconvective due to insufficient CAPE. Threats remain conditional. If any storms manage to initiate, the shear environment could support organization, but the lack of atmospheric fuel makes initiation itself highly unlikely. By tomorrow afternoon, the machine learning forecast for mid-afternoon local time continues the subconvective pattern. CAPE remains at 0 joules per kilogram across all parcel types. Wind shear decreases to 18 meters per second through 6 kilometers. The lifted condensation level becomes quite elevated at 2400 meters above ground, making it even harder for surface parcels to reach their condensation level. The 700 to 500 millibar lapse rate sits at 6 degrees Celsius per kilometer, showing moderate instability aloft, but without low-level moisture and CAPE, this doesn't translate to storm potential. All severe weather indices remain near zero, reinforcing the subconvective assessment. The hodograph reveals a fascinating wind profile that would be quite favorable for supercells if we had sufficient instability. Starting near the origin at the surface, winds veer dramatically with height, creating a curved arc that extends to nearly 60 meters per second at upper levels. This produces 133 square meters per second squared of storm relative helicity in the lowest kilometer, and 340 in the lowest 3 kilometers. The right mover bunkers vector point south-southeast, meaning any supercells that did develop would track toward the south-southeast. The left mover vector indicates movement toward the northeast. With 6 kilometer shear at 50 meters per second, we have more than enough turning and speed shear for rotating updrafts, but it's like having a perfectly tuned engine with an empty fuel tank. Bottom line for Wagga Wagga, today presents a classic case of strong environmental wind shear meeting insufficient instability. The Australian Severe Weather Potential Index rates conditions as marginal with a score of 29.8, driven primarily by the discriminant value crossing severe thresholds. However, all threats remain conditional. If storms somehow initiate through local convergence or terrain effects, they could quickly organize given the shear environment, but initiation itself is the major limiting factor. Always consult the Bureau of Meteorology for official warnings and forecasts. This analysis is provided by Distant Curve Remote Area Telecommunications. If you found this helpful, please like and subscribe to support continued severe weather coverage for remote Australia.